3. Unit number 3 has 2 chapters, chapter 5 and 6. Again, both chapters together will be due by March 1st. If you want to work in a timely fashion, you're more than welcome, and that's what I recommend you do. Don't wait till the last minute to turn it in. There are already people who have done that to themselves in the first unit, did not do everything, did not do anything to doing it partially. That is the reason they're failing the class right now. Unit 1 is already closed. I already gave 3 weeks over after the due dates, still didn't turn in. So I closed the unit and they already lost 400 points to 300. Some lost 200. So now moving forward, don't do that to yourself. You still have units 3 and like unit 2 with chapters 3 and 4. If you repeat the same thing again, you will lose another 400 points. So think about it. If you're 800 points down at the beginning of the semester, how will you manage a good grade in the class? So think about it. So that's why it's very important moving forward. You keep on top of your stuff. Otherwise, this will be a repeating process. I see that same people who did not do anything or partially the first unit are the same people who didn't do a thing in chapter 3 or 4, and it's due by midnight tonight. And I haven't seen a single thing from them. So I may wait maybe another few days, and then I'll close unit 2 too. Here you go, 400 points down the road again, down the drain again. So don't do that to yourself. Your grade is important, so you got to pay attention to the deadlines, timelines. For a reason, I've been giving you guys a little bit more time, and still, if people are falling behind, I mean, that's certainly poor planning on your part. So plan it better so that you don't lose these points. So we'll now be moving into our chapter number 5, which is about systems analysis and design, phase number 2, second chapter in this phase. And in chapter number 4 that we covered last week, that was the chapter in which we talked about the future chapters. So there was a hint in chapter 4 to chapter 5, which is about data modeling and process modeling. So there's a lot of diagrams involved in this chapter. But when it comes to chapter number 6, it is a little bit more heavier on modeling, but it's more geared towards programming. So chapter 6 is modeling for an object-oriented programming language. Chapter 5 is modeling for a process and the data. So they have a different take on, different approach towards things. Chapter number 6 is about object modeling. Chapter 7 is about development strategies. And then we go into phase number 3, which goes into UI and the data design and system architecture. Okay, so, but for now, let's concentrate on chapter number 5. In chapter number 5, we will be covering following topics. Oops, let's go back. Chapter 5. Okay. So these topics include relationship between physical models and logical models, relationship between logical and physical models. Once you understand that, we will then be looking at, okay, how do you perceive an application? So you're looking at an application from a bird's eye view as a single unit. But that single unit then further needs to be exploded and decomposed. So we'll start to look at that when we look at the data flow diagrams. So as you can see, bullet point number 2, all the way down to bullet point number 8, majority of this chapter revolves around data flow diagrams. How you decompose them, how you build them, what are data stores? What is a data flow? What are external entities that work on your application? How do you explode it? How do you further explode it? When you stop exploding, all of these things are part of the data flow diagram. Then linking us to data dictionary, the importance of data dictionary, why do you need one? And then finishing it off with process description tools in modular design. So we'll be looking at decision tables and we'll be looking at decision trees. That's another concept that we will learn towards the end of this chapter. And of course, while we are progressing through the chapters, we will have some breakout room discussions, and also we will have some breakout hands-ons today as well, especially in the place where you guys have to do your decision tables. That area especially, we want to be able to do some of that. Okay, so moving into the chapter, very first topic, logical versus the physical model. Logical model is where you start answering the question, what is the system supposed to do? What is it that I am designing, and what is it that I'm trying to accomplish? And when it comes to physical model, you're simply answering the question, how I will make this happen, how the system will be constructed from a logical conceptual idea to an actual physical implementation. That's the journey between logical model to physical model. Analysts must take a four-model approach. What is a four-model approach? Well, you need to have some logical documentation of an existing system, physical documentation of an existing system, logical documentation of the future system, and physical documentation of the future system. And these documentations can be called models, or they're called models rather. So this is a four-model approach. Analysts prefer to take this route. If the prior models do not exist, sometimes they try to reverse engineer those models. Again, it's a time-consuming process. The disadvantage is that the four-model approach is time-consuming, resource-consuming, not cost-effective. It just gives your analyst this peace of mind that whatever I'm doing is following some kind of a logical train. Then comes the data flow model, is when you start to actually design your model. What is a data flow? Well, data flow uses several different symbols to show how the system transformation happens. Where is the input coming from? Where is the output going to? Again, it is very difficult for somebody in your shoe to not think like a programmer here. But do not think like a programmer when you're looking at data flow diagram. When I talk about inputs, we are not concerned about parameters, their data types. We are least concerned about the programming logic. We don't think like a programmer. We do not need to know the nitty-gritty details. We do not need to think like a database developer. We don't think anything like that. When you start seeing numbers, when we start exploding the system, do not think numbers as the sequence of execution. It's very common for programmers that as soon as they see numbers, they start to think like a linear program logic. Okay, the number one has to happen first, then number two, then number three. No, number 1, 2, 3 here is only a number, not a sequence of execution. So just a few pointers to help you understand this chapter a little better. Do not think like a programmer and do not apply logic everywhere, okay? There may be some places where you may have to do that, but not everywhere. So data flow diagram uses various symbols to represent an idea, like an entity relationship diagram. When you guys learn about entity relationship diagram in the DB2 course, entity relationship diagram has table 1, table 2, table 3. That doesn't necessarily mean the data will be flowing in and out in the same order, exactly the same way. In chapter 6, you guys will be learning about object modeling, which is using UML. Chapter number 9 talks about entity relationship diagram. So you will be seeing that again in chapter 9, which you already learned in DB2. Okay, so data flow diagram, also called DFD, shows how the data moves in an information system from one process to another, how that movement happens across the board. Okay. In order to make this possible, we use some symbols. These are not the only two categorizations of symbols, but your book talks about two of them. One is called Gain and Sarsen symbols. Another one is called Jordan symbols. Your book uses Gain and Sarsen symbols, doesn't use Jordan symbols, okay? Okay, so when you start looking at your application and you're looking at a process, doesn't matter how complicated it is or how simple it is. A process will always be drawn like a rectangle, a cornered rectangle, a rounded rectangle, okay? Anytime you need to show a flow, like a flow chart, okay, a flow of execution, you will use an arrow, which is called a data flow. It shows the direction in which data is going. Either the data is coming into the process or the data is going out of the process, so the direction of the arrow will be drawn accordingly. And then you will have what we call data store. The data store could be a table, could be a file, could be a physical file, could be a logical file, could be an XML document, could be a JSON, doesn't matter what it is. It is a place where things needs to be stored. That's it. That's a data store. We do not worry about the underlying logic. We do not worry about the vendor. We do not think about the storage. Nothing of that sort matters over here. All we are concerned about is a place where the data gets to be stored, and the data needs to be retrieved from that place. And then finally, the external factors that are affecting your system or process from outside, they are called external entities. For example, if you're designing a system in which a customer needs to talk to a banking process, so customer is an external entity and the banking process is the process. What connects the two is the data flow. And if the process needs to grab data from a data store, then you will draw the symbol like student data store. Okay, so these are the four symbols. Either you will draw symbols from gain or you will draw symbols from the Jordan. Does anybody has any questions so far? All good? Okay. Now, what I would like you to do is go to unit number 3 and open chapter 5 items. There's a folder for you called chapter 5 items. And I want you to click on the very first article there called data flow diagram. When you do that, start scrolling down. And you will see that you have different kinds of Jordan. You have a Jordan and code, that's one kind of symbols. You have Jordan and DeMarco, that's another kind of symbols. And gain and Sarsens is another kind of symbols. Okay. Well, but in all three of them, you will have the same thing: external entity, process, data store, and data flow. Exactly the same stuff, okay? How these symbols differentiate from each other? Not really. They don't. Other than some basic stuff. External entities are drawn similar. Your book uses a slightly different shadow approach. Process, circle versus a rounded rectangle. Data store, there is a line in the middle of the data store. You can gain and Sarsen, where there's no line in the Jordan approach, okay? And then you have this data flow arrow. Okay? So that's how these diagrams will look like. As we start exploring them, you get to see some of that stuff. Okay, so let me close that. Let me now open the second one, the data flow diagram, article number 2. And it talks about, how the systems are exploded and how we start building these diagrams. Okay, again, stuff for you to maybe look at outside. This article actually brings in 2 more symboling. One is called SSADM, and the other one is called unified. And you can see there is a slight difference between the symbolization used in this article. Arrows are somewhat similar except for unified. External entities are used as a stick figure in unified. Process is more like a rectangle without rounded corners. And data store is a solid box with an annotation at the top. Some basic differences between the different styling, but the idea is exactly the same. What you can draw in one, you can draw in the other one. So just wanted to show you those extra resources that are available to you. Now let's come back to the chapter itself. Process symbol. What is the purpose of the process symbol? It is to receive an input and produce output. For instance, the process for calculating pay uses two inputs, which is pay rate and hours worked. But again, when you are doing this kind of stuff, you do not need to worry about the variables. It is only for the sake of your understanding, author is bringing in these extra words in parentheses. So when it says two inputs to produce one output, that's what he meant. Processes can be very simple or quite complex. In a typical company, processes might include calculating sales trends, filing online transactions, and blah, blah, blah. But again, at this level, you do not need to code anything, no need to even write pseudocode. It's just you write the name of the process. For example, if the process talks about withdrawing money, that's it. You draw a little process, you write withdraw money. That's it. You make necessary arrows. Okay, to withdraw money, I need to talk to a data store for a customer. So you make an arrow to the customer data store. I mean, like simple things like that. You do not need to know about any underlying details at this point. Okay, now let's learn about some of the rules. Okay. In a data flow diagram, a process symbol can be referred to as a black box. Okay, is black box is a good thing or a bad thing? Well, it is called a black box for a reason. That means it is where the inputs and outputs and general functionality of the entire system connects. That's why it's called a black box. However, when people draw these diagrams, they sometimes make some mistakes. We will be looking at those, what not to do. But that's coming forward. Okay, let's move on to the next one. Data flow symbols, on the other hand, simply show you the flow of the data. It's like an arrow with some markings on it, showing you, okay, this is what's going in this direction, or this is what's coming out of here. You just mention things in words. You just label by words. That's about it. The symbol for a data flow is a line with a single or double arrowheads. That's about it, okay? Now, let's see what is good about these things. Sometimes what would happen is you will have one input coming in and one output going out. Perfectly fine. Nothing wrong with that. It is also possible one input coming in, more than one outputs going out. Two inputs coming in, but one output going out. One input coming in, another, like an output going out, but that output actually becomes an input for the next process in line. So there are four things to learn from here. One input, one output, one input, two outputs, two input, one output, and an output of a process can be an input for the next process in line. All of this is valid and correct. Now let's see what is not valid and what's not correct. There's three things that you have to be very careful about. There should not be a spontaneous generation. There should not be a black hole. There shouldn't be a gray hole. By spontaneous generation, we mean magic. For instance, your process produces an output, but there is no mention of where in the world it's getting the data that is producing an output. That's called the magic, the spontaneous generation. Black hole is when the process only receives input, but that input goes nowhere. That's like a black hole, absorbs everything within. And gray hole is a process that has at least one input and has at least one output, but the output has nothing to do with the input. Output has nothing to do with an input. For example, you have a process to generate car price, but you're taking an input as an address of the dealership, and what your output is the price of the car. There is an input, there is an output, but they're not related. What does the price of the car has to do with the address of the warehouse or of the dealership? So they're not related. So these are what is being talked about here. Apply insurance. Only the outputs are coming out. We have no idea where in the world the input is coming from that it is generating so many outputs. That's spontaneous magic. Second one, calculate growth space like a black hole, only accepting input, but that data is going nowhere. The next one is a gray hole where the date of birth is coming and the grade is getting out. How in the world a grade is getting out based on the date of birth? So this is all incorrect. Any questions so far? Okay. Let's go to the next step. Data stores is a place where the data needs to be stored to be retrieved at a later time. You can have one or more data stores, and a data store symbol looks like an open rectangle on one side. However, let's look at what is the correct usage of data store. One of the correct usage of data store is that one process feeds into the data store, another process takes data out of the data store. Another example could be one process feeds into the data store, but another process can feed in and give back, can take data in from a data store and feed something back to the data store. Another example could be several processes are hooked up to a data store. Some are putting data in and one is getting data out. So these are all okay, perfectly fine ways of using a data store. However, what is not okay is this. Two data stores cannot talk to each other directly without a process in between. There must be a process between the two data stores so that they can communicate with each other. What's wrong with this data store? Data coming in, not going anywhere. It's a dead end. Why are you even storing the data if you're not feeding anybody? Or data coming out of the data store, but how? Where's this data coming from that it is spitting out? So all of these are incorrect data store examples. Okay, let's move on to the entity symbol. An entity is a rectangle which may be shaded to make it look three-dimensional. However, in some cases, it may not. Data flow diagram entities are also called terminators because they are data origins or final destinations. Systems analysts call an entity that supplies data to the system a source and an entity that receives data from the system a sink. An entity name is a singular form of a department, an outside organization, or other information system, or a person. Here are some examples of valid external entity usages. Number one, an external entity calling a process to send information in. Another good example, an external entity receiving information out of the process. Another good example is an external entity sending information into the process and receiving something back. Another good one is an entity is asking one process to give me the data and then uses that data to feed another process. All four of these are valid. What is not valid is this. Two external entities cannot talk to each other. Two external entities cannot communicate without a process in between. An external entity cannot directly talk to a data store without a process in between. And finally, in both of these last two cases, it can neither send in information into the data store directly, nor can retrieve data out of the data store directly. It has to always come through a process. Any questions so far? after looking at the rules for all three symbols? So how many symbols did we look at in total? Yes, guys?
Four.
Four. Okay. And out of the four symbols, the rules are on how many symbols?
Two.
Three. Data store has rules, process has rules, and external entity has rules. Okay. Arrow is the only one that doesn't have any rules because it makes everything work. Now let's sum up all these rules in one place. Two processes can talk to each other. Okay. A process can talk back and forth with an external entity. Good. A process can talk back and forth with a data store. Good. Two external entities cannot talk to each other. An external entity cannot directly talk to a data store, and two data stores cannot talk to each other. Okay? Everybody good with these rules?
So it's kind of the process has to be with the data stores and the external entities.
Exactly. Without process in between, you cannot make two external entities talk to each other. A data store cannot talk to another data store, or a data store cannot talk to an external entity. There must be a process in between. Okay?
That makes sense.
Okay. Now let's look at drawing the data flow diagrams. Okay. So in order to draw the data flow diagrams, so during the requirements engineering interviews, questionnaires, and other techniques were used to gather facts about the system and was explained and all of that stuff that we learned in the previous chapter. Using all that information, what you need to now do is you need to sit down and say, okay, you know what? I am designing a grading system. On this grading system, following people will be working. Students will be working, student record system will be working, and instructor will be working. These are the three external entities that will work on my system. Now, this is a very, very crucial step. Why? Because once you come up with your external entities and you put them in a diagram and you say, okay, this is my context level 0 diagram. Why is it called context level 0? Because look at your system in the middle. It has 0 on it, means the system is not yet exploded. The system is still considered as one unit. When the system is considered as one unit, you define the external entities and say, you know what? Student will send something in and will receive something back. Student record system will send something in, will receive something back. Instructor will send something in and will receive something back. We are not concerned about the data stores at this level. All we want to know is how many external entities will work on this system. That's about it. The system itself will not be further defined. It is all as one big unit. That's it. So if you are doing a data flow diagram for a flight simulation system or airline reservation system at this level, all you will do is draw one rectangle and write on it airline reservation system, 0, and the number of people that will work on that system as external entities. That's it. Done.
So would a good analogy for the process would be like the center of the solar system then of this when you have external.
No, at this point, you are considering the whole solar system as one unit.
Yeah.
Okay, you have
That's what I
not
was
yet
trying to get
started
at.
dividing into stars and comets and meteoroids and planets and satellites. You haven't done that yet. You just say the
Okay.
whole solar system is one unit of work at this point.
Okay.
Okay. Now, after that, you take this diagram into the next level is when we start exploding the context level diagram and take it from process 0 to process 1. So in the next course, you will be looking at two separate examples. You'll be looking at an example of a grading system, and you will also be looking at an example of order systems. You'll look at two separate examples. So here is the order system example. Is this also at context level 0? Figure 511?
Yes.
Yes. Again, we are treating the entire order system as one unit, and we have already talked about that these are the 5 external factors that are external entities that will work on this system. Now, some external entities are only on the receiving end. Some external entities will do both, and some external entities will have different inputs and different outputs. Like customer. Customer will be sending in payment as well as the order. Customer will receive the order reject notice and also an invoice. But underlying details, we do not know yet. So that's a context level 0 diagram. Okay. Now, once you draw your context level 0 diagram, when you're drawing it, you always put the 0 on the main unit and you do not label or number anything else. Now, let's have a look at this one. Okay, so here is my context level 0 at the top. So what we decided to do was we decided to take the 0 and we said, okay, you know what? Our grading system will now be further divided into 4 components. One component's job is to establish gradebook. Another component's job is to assign the final grade. Another component's job is to grade the student work, and another component's job is to produce grade report. Again, 1, 2, 3, 4 is not the sequence of execution. 1, 2, 3, 4 is only the numbering scheme. Okay, these are just 4 processes. That's about it. Now, remember how many external units we had? 3. Now we need to figure out, okay, now that we have exploded the context level diagram into 4 components, which of the external entities will work with which of the 4 components? Because not every external entity will work with all the components. Remember, you cannot add any more external entities. You can only have 3, but you can fit them in different places in the diagram. So for example, you can say that student will only work with grade student work. Student record will work with assign and establish, and instructor will work with produce and establish. So this is their working. Now, student record is grabbing information from assigned final grade and is pushing information into established grade book. What information is it pushing into established grade book? The class roster. Okay, what is instructor getting out of the established grade book? Well, is pushing in the grading parameters. Okay, so where in the world established grade book is taking this information into? Well, established grade book, whatever it receives from the outside, it pushes that into the grade book. Okay, so what does grade book do with it? Grade book allows the assigned final grade to receive the grading details. And also, assigned final grade can push in the final grade into the gradebook. Okay, is there anything else that comes into gradebook? Yes. Student can submit work to the grade student work process, which can then send in the student grade into the gradebook. Okay, what else gradebook can be used for? Well, we have another process which is used by instructor called produce grade report, which is getting all the class details from the grade book. So this is how you will design your processes, your external entities, and your data store. And in this whole working, you will not see a single programming logic or database logic in place. It's merely process building and proper labeling. You guys follow this? Okay. Now, having done that, we need to also understand another concept called a diverging data flow. What is a diverging data flow? This arrow that you see over here that is coming out of the assigned final grade, one end is going to student record system, and other end is going into the grade book. This is called a diverging arrow. Okay. Now, next concept. When a data flow diagram is exploded, whatever it exploded from, the higher level, it's called the parent diagram. And wherever it is going into is called a child diagram. Okay? When a set of data flow diagram is created, you got to remember one thing, that you can only keep exploding till you reach a point where you are like, oh, that's it. I cannot further explode it. That is exactly what will eventually convert into your functions. Now, I'm trying to link this to your programming knowledge. So when you say, okay, I cannot further explode it, so that's it. That's the dead end of this process. This process is now at a point where it is a single unit of work. So when programmer takes this, and not programmer, rather the designer for the programmer takes this and like, oh, okay, let's pseudocode this or let's flowchart this now because it is now at a point where it cannot further explode. And what would you call this that cannot further explode? Functional primitive. When a process reaches the state of a functional primitive, that means the process is now a single function and cannot be further subdivided. So it sort of kind of reaches an atomic state. So it's totally up to you when you're designing your data flow diagram to realize, okay, that is now good enough. Okay.
So
Yeah.
like prime numbers, it can only be divided by itself.
No. Don't get it to that. Rather, look at it like a getter or a setter. When you reach a point where getter can only return one value and a setter can only set one value, that's the atomic state for getter and setter. You cannot further decompose it.
So
Or
it would be basically done then.
yeah, exactly. That means you cannot further divide this into anything else. So again, we are not thinking like a programmer at this stage, but just to help you understand what exactly the primitive, functional primitive means is it is at a point where the designer thinks, okay, now that's a complete unit of work. If I need to find an average, that's it. You know, I cannot further subdivide an average. This is where the programmer will do all the average work. Whatever it needs to do, pull the data from the database, pull the data from whatever sources the programmer needs to do. Whatever code programmer will write, that's it. We will not further subdivide, calculate average. Similarly, you come to a point where you're like, okay, somebody wants to add another book into a library. So it's an add book process. That's it. There's nothing more we can divide this into because the process is very self-defined, add book. So now programmer has to come up with a form, a UI designer has to come up with a form that will feed the data into the process through parameters or through a form submission like you guys are learning in PHP or have you learned in JSP.NET. And then that process will take the data and feed it into the database. And that could be 20 lines, 30 lines, 5 lines. I don't care for all of that at the data flow diagram level. Does that make sense? Okay. So now the order fulfillment that we saw before, now we will explode that. So the order fulfillment was further divided into 3 components: fill order, create, apply. Okay. How many external entities were there in the first diagram? Let's go back so that you guys can see it again. Was it this one? No, I think it wasn't on the page before this one. Okay, right here. Okay, how many external entities?
5.
5. Okay, now notice here, we have to maintain 5. We cannot add 6. We cannot bring it down to 4. It has to be 5. Even an explosion. Now we need to look at which of the external entities will work with which process. So we divided the ordering into 3 processes: fill order, create invoice, apply payment. And then this is the point where we can add data stores. There is no limit to the number of data stores you can add. You do not need to define the data stores ahead of time. You can bring in the data stores as much as you want while you start exploding it further and further. The only thing that cannot change are external entities. Otherwise, you can add more processes, you can add more data stores. That's totally up to you. Now comes that the fill order is used by 2 external entities. One feeds in, another gets thing out of it. Create invoice is also the same way. One external entity feeds in, another one takes out. And then there's a diverging arrow. When create invoice sends invoice to the customer, also sends the information to a data store called accounts receivable. Accounts receivable is a data store from where apply payment sends in the payment detail or receives an invoice details back. And then apply payment works with sales department, different from bank account, different from accounting. Because sales department is only interested in commission, where a bank is only interested in bank deposit, and accounting is only interested in cash receipts entry. So each external entity has different needs for the same process. Okay, so that's basically how it will be perceived as at this level. Okay, now let's go into lower level data flow diagrams. Now what happens is you may take one of these numbers, 1, 2, or 3, and you're like, you know what? This process can be further exploded, and I can do more things from this process. So in order to accomplish that, let's say you start looking at your first step, which was this guy, fill order, and you start zooming into it and start exploding that. So let me open this in a different tab. Okay, look over here. So now what you do, you start numbering it like this: 1.1, 1.2, 1.3. What does that mean? The first number represent the upper level. The second number represent the breakdown of that upper level. So these are the 3 components of that upper level process, which was called fill order. So these are the 3 main things in the fill order. The order needs to be verified. Either you prepare, reject, notice, or you assemble the order. Now the external entities, look at it. How many external entities are working on fill order? 2. So when you explode it, notice that you still have 2 entities working on it: warehouse and customer. Now warehouse and customers can work with different subcomponents of the big guy, but you cannot add more or remove an external entity that you had before. Okay, now how many data stores do we have here? None. But now that we started exploding it, we realize we need data stores, because where's the data coming from? Where's the data going to? So now you can add data stores. So you realize that, okay, verify order needs to get its data from somewhere, which could be from a customer data store. Okay, then where in the world is the customer's data store getting its data from? Well, prepare, reject, notice will feed the data into the customer, and the customer can then notify the credit status based on the data coming in to verify order. Okay, so what about products? Well, product gets its data from assemble order, and assemble order can also get the picking details from product order, and product order can also fulfill product detail, can fill in product details into the verify order. So that's how you are pretty much designing everything around. So this is how you may also draw the same diagram as some systems analysts drop external entities to minimize the diagram, and they probably may list it in writing somewhere. But again, this is another approach of doing things. Okay. Now have a look at this diagram. I'm gonna open it in here. Okay. Now, remember we had 3 processes in the order fulfillment. We already looked at the fill order. Now let's look at apply payment, the bottom one. Okay. Let me zoom in a little bit here. So that itself is then divided into 4 entities. How many external entities were working on apply payment? 4. We had customer, sales department, bank, and accounting. We still have 4 entities. But notice, apply payment was directly serving 3 different external entities at the same time. So as a programmer, I would have to define different processes for that purpose. As a data flow diagram person, I would have to realize that, yes, apply payment as a single process cannot serve 3 unique distinct needs. Rather, it needs to have 3 separate processes to fulfill 3 separate needs, because somebody needs a commission, somebody needs a receipt, and somebody needs to know about the deposits. Okay, where in the world is information coming from? Well, you know what? For the accounting entries for deposit, that could easily come from daily payments. But for the commission, well, that needs to be calculated and be passed over. But who will do that? Well, we'll have another process called post payment, which will get the data from account receivable and will then fill in the pay commission with whatever data needs to be done. And then pay commission will then provide the result to sales rep. So this is how you are envisioning the diagrams and drawing them based on how the business flows, the business processes flow within your application. Okay, so this is what we started out with, for example, and then we start exploding, 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 and then we go like that. Okay? Now, what I want you guys to do is I want you to go to page 160 and look at case in point 5.1. I will be putting you guys in a breakout room where you will analyze this diagram and make a list of what is wrong with this diagram. How many rules is it breaking? Okay, that's page 160, case in point 5.1. And just give me 1 minute. I'll create the breakout rooms. And we will put you in these breakout rooms. Okay. And we will set a timer of, let's say, 18 minutes or 15 minutes. Let's do 15 for this one. Okay. Here you guys go. Okay. So one of the mistakes that we see over here is that assign advisor is a miracle. Why assign advisor is a miracle?
Spontaneous generation.
Exactly. That's where the magic is happening, right? Okay. Check open classes. What's wrong with this guy?
He has no output.
It's a black hole, right? Right. Calculate grade. Calculate grade. What's wrong with this guy?
Student ID number has nothing really to do with calculating grade.
Okay, so what kind of problem is this one?
Gray hole.
Gray hole problem. Okay. Let's look at instructor. What's wrong with instructor and student?
There's no process between them.
Yes. Okay, so that's what's wrong here. Okay. Okay, what else is wrong with instructor?
Class roster to instructor.
Yes, data store and external entities cannot directly talk to each other. Okay.
And then class roster and seating chart.
Oh,
Right?
Yeah,
Because they're both data stores.
yeah, I don't know why this guy is coming in. Just 1 second. Let me get rid of this notes section. Okay. Okay, so we have two data stores trying to talk to each other. That's also a problem. Okay. So how many problems did we identify so far?
6.
We go 1, 2, 3, 4, 5, 6. Okay. Which one is missing?
So both seating chart and grades just kind of go nowhere.
Seating chart and
Grades.
grades.
So they just
Oh,
get
you
information stored and nothing happens with that information.
okay, yeah. So grades and seating chart, both of these entities are acting like a black hole, means information coming in, but it's not going anywhere. Yeah, so these are the 7 problems.
What was the problem with assign advisor?
Assign advisor, we don't know where it is getting the data from that it is passing to meet with advisor.
Okay.
It's spontaneous. It's a Disney character. It's magic. Okay, did everybody got it now? Okay, let me clear all the drawings. And just 1 minute. Where is the chat? Okay, so I just posted all this information in the chat so that you guys will have it in writing. In case if you want to copy that from the chat and put it in your notes. Got it?
Yep.
Awesome. Okay. Let's move on to our next topic called data dictionary. Data dictionary is a repository of information. So the data comes here, the data gets standardized here. You need to give each item its official name, its description, what item it comes from, why it is there, if it is a variable or a data element, what is its data type, all of those little nitty-gritty details that you want to store about any item will go here. So data dictionary or a data repository is a central storehouse of information about the system's data. An analyst uses the data dictionary to collect, document, and organize specific fact about the system, including the contents of data flow, data stores, entities, and processes. So when it comes to a data element, which is also called a data item or a field, that's a single smallest representation of data. These data elements are placed inside a record or what we call a data structure. When you're designing your tables and entity relationship diagram, it is this data structure that you are converting into a table. When you're designing your physical files, it is this data structure that you are converting it into a record format. So data structure is like a record format with the name and bunch of fields and the whole 9 yards. So a record is a meaningful combination of related data items. Significant relationship exists among the items in a data dictionary. For example, data stores and data flows are based on data structures, which in turn are composed of data elements. Data flows are connected to data stores, entities, and processes. Accurately documenting these will help you create better system, right? Because it's all linked. Documenting data elements. When you are putting a data element down in a data dictionary, you need to make note of the data element's name. You need to come up with its aliases, its type, its length, and all of this information will then be taken by the database developer and the programmer when they're defining entities, when they're defining fields, when they're declaring variable, when they're coming up with instance properties. It's all coming from your data dictionary. Acceptable values, default values, source, where's the data coming from? Security measures, that maybe the database administrator has to take some security measures. Maybe the network administrator has to take some security measures. Maybe the programmer has to write some security code. All of that needs to be specified here. Who is responsible for this data item? And some description and comments. Now, if I take you guys back to your last week's DB2 class, not this week's, but last week's DB2 class, for those of you who are taking DB2 this semester, what was our main focal point that we spent the most time on last week?
Constraints.
And which particular constraint we spend the most time on?
The check constraint.
Check constraint, right? What is the whole idea behind check constraint?
Checks if a value is within a given range.
Yep. Is it this bullet point that I just selected? Right? That's where the database developer is getting his or her info from. That what are the acceptable values for this field in the data dictionary, that will help me write my check constraints. Okay? So this is how a typical entry may look like. Here we go. We need to report on the label. We need to report on the description. We need to report on the alias that will be used by the developers. So when I'm coding this field, I'll write the name SSN because I cannot write the name social security number with spaces and so on and so forth. The data type is and the length and the default value and acceptable values and all of that stuff. Okay. Now let me close some of the other pictures I had opened before. Now let's move on to the next item. Documenting the data flow, how the data is coming in. What is the name of the data flow? What is the description of it? What's the alternate name of it? Where is it originating from? Where is it going towards? Each data flow represents a group of related data elements called a record or data structure. Similarly, what is the volume and frequency of this? How often would you need to be passing this information over? This kind of information can help developers create better solutions to the problem. For example, if 3,000 records are coming in every minute, can my servers handle that kind of network traffic? Can my network handle that kind of a network traffic? All of these factors can be factored into the volume and frequency. So accordingly, if the volume and frequency increases, my database administrator has to now improve the performance and fine-tune the database. Documenting the data stores. So every data store needs to have a name, description, alternate name, attributes, whatever information that you need about a data store now needs to be stored right here. For example, if the data store is about availability, so you basically the alias is available or the label is in stock and it has 3 fields called the inventory change, the picking detail, and the product detail, and then you need to come up with their data types and their lengths and the whole 9 yards. And then you will be able to add more items to the data store, remove an item from the existing data store. In case if you decide to add a field to an existing data store or to your existing data structure, This is exactly where you will come and add a field and everybody will be notified of the change. And then the database developer will issue an alter command on the table, alter table, blah, 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 add column, blah, blah, blah. An additional column will be added. Then the programmer will know that next time I run a report, I need to pull one extra field. So we're going to update all the reports and include one extra column. So all of these things are linked. Similarly, you got to document the processes. For example, if you have a process called verify order, so somebody has to go there and say, oh, okay, it needs to have a description. It needs to have what inputs are coming in, and it needs to have what outputs are going out. Just a list of them. No need to worry about their data types. No need to worry about their field lengths, nothing. It just list how many inputs come in, how many outputs go out. Just list them. So if order, credit status, and product details are coming in, well, the outputs could either be accept an order or reject an order. So it's like an if condition. But you don't mention that here because this is not programming. This is a data dictionary. Then you need to start documenting your entities. These will eventually become your tables or may eventually become your classes. So these are your entities or your physical files. Doesn't matter. I mean, like whatever it is, but an entity needs to have a name. An entity needs to have a description. An entity needs to have the field that describe the entity. For a table, these will be the fields. For the class, these will be the instance attributes. And finally, you need to have a data dictionary report, which allows you to list everything in a reporting form. These are my entities, and these are my data flows, and these are my processes, and this is this, and this is that, all of thing in the report format. Easy for anybody to follow these instruction sets when designing things. And these reports could be in the PDF format. These reports could be in a paper printed format, whatever is the allowed format for your tool. Then comes a process description in modular design. A process description documents the details of a functional primitive. Who remembers what was functional primitive? Anybody remembers functional primitive?
That's when the functions have been broken down so far that they cannot be broken down anymore.
Exactly. Okay. That's exactly where you need to start documenting them because that's exactly what your underlying processes are. And you will start coding your modular design. The fourth component of programming. Okay. Now there are two kinds of approaches you can take. You can take an object-oriented approach, or you can take a procedure-oriented approach. In a procedure-oriented approach, everything is just broken down into atomic processes or functions, and then these functions talk to each other. These functions can be across multiple files, but functions are not tied to a program. They are open for anybody to access them. And you pretty much design everything like a menu in a menu bar with submenus. That's exactly how procedure-oriented programming works. On the contrary, an object-oriented programming allows you to create classes. Within classes, you have attributes, you have getters, you have setters, you have inheritance, you have polymorphism, you have aggregation. All of that stuff is missing in the procedure-oriented world. Typically, programmers will say, in a typical school setup, the three building blocks for programming are sequence, selection, iteration. I disagree with that a little bit, and I rather follow those programmers who say there are four building blocks. What's a fourth building block? I know Alan has been telling you guys over and over again, sequence, selection, iteration, right?
Yeah.
Okay. I am, because he is in that group of programmers that emphasize on these three. I am in that group of programmers who emphasize on all four, which is the fourth one, which is, by the way, built from these three, but offers a lot more than these three can offer you. That component is the building block of all programming kinds. Procedure or object doesn't matter. What is that fourth component?
Modularization.
Modular, exactly. Your functions, your procedures, right? Modularization. Modularization is the core of today's programming. Now think about it. Can you create an object without any getters, setters, constructors, static, non-static functions? No, you can't.
They all serve their purpose
Yeah, there will
in
be
the
nothing.
program.
Right. And in a procedure-oriented world, you cannot have a procedure-oriented programming until you have procedures. Yes, procedures are sequence, selection, or iteration based, but procedures are an entity by themselves because they allow you to divide your program logic into reusable components, and they are the foundation of component-based programming. They're the foundation of service programs. They are the foundation of everything that you see in the programming world these days, a level up from sequence, selection, iteration, yet an extremely important part of program. That's my take on it. That's why I say four things. Yes, modular design is divided into three things, but modular design itself is one of the constructs of programming. Sequence, well, everything has to go in a flow. 1, 2, 3, 4, always 1, 2, 3, 4. Selection, on the other hand, allows you to make decisions like if conditions, switch cases, and iteration allows you to go in a loop. It could be precondition, postcondition, finite, infinite, doesn't matter. But it's a loop: for, while, do until, whatever the language allows. Okay? So sequence, selection, iteration. I don't have to spend too much time trying to explain these concepts to you. You guys already know what they are, hopefully, right? Now comes structured English. Structured English is not pseudocode. Just remember that. Structured English is a step down from English and a step up from pseudocode. It doesn't have a feel of a program like pseudocode does. Let me show you an example of this. Okay, structured program. Have a look at this. This is a process called verify order. The verify order process, you can see at the top, it says input output data flows. Pseudocode doesn't mention anything like that at the beginning. These are my inputs and these are my outputs. It doesn't say that. Now look at the rest of the logic. It says for each order, okay, pseudocodes can do that. But look at the if condition. You will never write a pseudocode like this. Pseudocode will never have a variable with spaces in the name. Accepted status code equals to, and you will never write a letter without single quotes or double quotes in pseudocode, because pseudocode is very close to programming, but this is not. Here, everything is English, but structured like a program logic. Output accepted order. You will never write it like that in a pseudocode. You will always put order, accepted order in double quotes, or rejected order in double quotes. So structured English is a bit different from pseudocode, but it's very close to pseudocode. So structured English might look familiar to programming student because it resembles pseudocode. Although the techniques are similar, the primary purpose of structured English is to describe the underlying business logic, while programmers who are concerned with coding mainly use pseudocode as a shorthand notation for the actual code. But the analysts would use this for a shortcut to understanding the programming logic. Okay? Following structured English rules ensures that the process descriptions are understandable to users. Next comes another very important component called decision tables. A decision table is basically a tabular model where you lay out your conditions and you lay out your outcomes. If these conditions are met, this will be the outcome. If these conditions are met, this is the outcome. That's exactly what you are putting it out. Tables with conditions. Tables could have one condition, two conditions, more conditions, doesn't really matter, okay? Let's understand it with the help of an example. Look at this example. We need to write a decision table that will verify order, and we are basically looking at business process with two conditions. Condition number 1, an order will be accepted only if the product is in stock and the customer's credit status is okay. All other orders will be rejected. Okay, so there are really 2 conditions. Number 1, order will be accepted only if condition number 1, the product is in stock, condition number 2, and the customer credit status is okay. Now comes the question, technically speaking, if the customer's credit status is okay, but the product is not in stock, can we order this product?
No,
What'd you say, Amruta?
no,
No, we can't, right? So customer's credit status is meaningless until
Unless
the
the
product is in stock.
Yeah.
Okay? Okay, now let's have a look at it. This is the decision table that we have come up with. So credit status is okay and product is in stock, I can accept the order. Credit status is okay, but product is not in stock, so the credit status is meaningless. Credit status is okay, it's not okay, but the product is in stock, I'm still not accepting it. Why? Because of and. But and has more weight towards product in stock and less weight towards customer's credit. But if the product is in stock, then customer's credit status has a weight. If product is not in stock, then customer's credit doesn't matter. And then if both of them are no, we cannot place an order. So if you look at it carefully, in most cases, you can't place an order. Both of them have to be there for you to be able to place an order because of an and in between the two. Okay, so having said that, this is basically what this product will hold. Now let's take this to the next level and say, okay, you know what? We will now make this slightly complicated by saying an order will be accepted only if the product is in stock and the customer status is okay, good enough. The credit manager can waive the credit status. What does that mean? That means if the product is in stock and the customer credit status is not okay, then the manager has the authority to waive that requirement and the product can still be ordered. Everybody follow those 2 rules, those 3 rules? Now let's put it in a decision table. Okay, so the decision table looks like this. One condition is the product status is okay. Another condition is product is in stock. Another condition is waiver from credit manager. We start laying out the truth table like decision making. All conditions true to all conditions false. So between columns 1 through 8, all conditions true, all conditions false, right? Now let's have a look at it. Number 2, credit is okay, product is in stock, manager not willing to sign the waiver. No. Okay. We'll worry about the outcomes of the next step, but let's first lay out the conditions. Credit status is okay, product is not in stock, and manager is willing to sign. Or the credit status is okay, product is not in stock, and the manager is also not willing to sign. Next condition, credit is not okay, product is in stock, manager is willing to sign. Credit is not okay, product is in stock, manager is not willing to sign. Neither the credit is okay, nor the product is in stock, but manager is willing to sign. And the last case is everything is a no. Now let's start analyzing this. Okay. If credit status is okay and the product is in stock, can the order be accepted? Yes. Okay. If credit status is okay and product is in stock, even though manager is not willing to sign, we don't even need the manager to sign because the credit status is okay. So the order will go through. Okay. Now, if the product is not in stock, like in both of these cases, none of the other conditions matter. Manager willing to sign or not, credit status is okay or not, that doesn't matter. You cannot order because it's not even there. Okay, now comes the 5th condition. Credit status is not okay. but product is in stock and manager is willing to sign on behalf of the credit. And you're like, yo, yeah, we can order, but we cannot order when the manager is not willing to sign. We cannot order even if the manager is willing to sign, but neither the product is there, not the credit status is there. And in the last case, also, we cannot order. So these are our outcomes. We're not done yet. This is only step one. Did everybody understand this step before I go to the next step? Okay, now let's go to the next step. In the next step, we will put dashes where it doesn't matter. The places, the things that don't matter, we'll put dashes there. Means if the item is in stock and the credit is okay, manager willing to sign, not willing to sign, meaningless. If product is not in stock, everything else is meaningless. So we'll put dashes down now. Columns 3 and 4. Column 5. Well, the credit status is not okay, but manager is willing to sign. Well, that's a unique case. Credit is not okay and the manager is not willing to sign. That's another unique case. And if the product is not in stock, none of the other conditions matter. Right? Okay. Now, if you look at all these 8 conditions, how many unique conditions can you identify? Only 4. Columns 1 and 2 are exactly the same thing. Columns 3, 4, 7, 8 are exactly the same thing. Column 5 and 6 are unique. As a result, we came up with this table. This is our final decision table. This, when goes to the programmer, can help the programmer write the conditions. The if conditions, the nested if conditions, and all of that stuff will then be based on this decision table. Said when the order is okay and when the order is not okay. Did everybody follow that? Okay. Now let's look at this example, figure 533, sales promotion policy. Now this goes a little bit complicated than the example above. Preferred customer who orders $1,000 or more are entitled to 5% discount. Another condition, but if you use the charge card, the store charge card, you get an additional 5%. Okay, good enough. Preferred customers who do not make a purchase of $1,000 or more will only receive $25 coupon. Now, my question to you is, okay, if a preferred customer makes a purchase of less than $1,000, but uses a charge card, will that person get an additional discount?
No.
No. Okay, just keep these points in mind. It doesn't matter you use charge card or not for a purchase of less than 1,000. The mode of payment makes no difference. Okay, all other customers who are not preferred, doesn't matter. They use charge card or they don't use a charge card. They make an order of over 1,000 or make an order of less than 1,000. All of those factors do not matter because you are not a preferred customer. You only get $5 off. Okay, everybody's clear on the rules? Now let's put it out in the table form. Okay, here is our table. Whereas one rule is preferred customer, another rule is order of $1,000 or more, another rule is you used your charge card, another rule is those are the 3 rules, right? And the criteria is either you get a 5% discount or an additional 5 or a combination, right? Or 25 or 5. Those are the 4 outcomes. Now let's look at the conditions. So we set our top part first. Everything yes to everything no. And in between, first 2 are yes, last one is no. First one is yes, second one is no, last one is yes. First one is yes, the other two are no. First one is no, the other two are yes. The first one is no, the middle one is yes, the last one is no. First two are no, and the last one is yes, and everything is no. So we just make 8 variations on the 3 conditions. Now let's start evaluating these conditions. If a preferred customer makes a purchase, makes an order of $1,000 or more, automatically qualifies for the 5% discount. So that check goes there, right? And if uses a charge card, another check goes there. But if a preferred customer places an order of $1,000 or more and doesn't use the charge card, well, you only get 1 X. If a preferred customer makes an order of less than 1,000 but uses a charge card, or makes an order of less than 1,000, a preferred customer, and doesn't use a charge card, it doesn't really matter. You only get 25 bucks. Okay, now if I am not a preferred customer, nothing else matter. I make an order of $1,000 or more, less than $1,000. I use my charge card or I not use my charge card. Since I do not meet the first criteria, I only get $5 off. Okay, now let's take this to the next level. In the next level, we need to take out anything that doesn't matter. If you're not a preferred customer, nothing else matters, right? If you did not made an order of $1,000 or more, then it doesn't matter you use charge card or not. Your preferred customer status makes no difference. If you use your charge card or not, don't use your charge card, because you will just get 1 flat $25 bonus. That's about it. And then this will lead us to how many unique cases do we have in this example?
4.
4, right? Column 1, 2, 3 and 4 is one case, and 5 through 8 is another. So we have 4 separate in this one. Everybody cool? Okay. Now let's go to the next topic, which is called the decision trees. Now we'll look at the decision tree of the same example. Decision trees go sideways from left to right. Okay. Same problem. So we start out by saying, okay, by the way, are you a preferred customer? No, I'm not a preferred customer. You know what? Nothing else matters. You only get $5. Oh, I am a preferred customer. So, okay, now let's talk about how much you're spending. If you're spending less than 1,000, it doesn't matter. You use charge card or not use charge card. Charge card doesn't even matter here. You only get $25 off. But if you're a preferred customer and you're willing to spend more than 1,000, now let's see if you're using our charge card or you're not using our charge card. So if you use our charge card, you get an additional 5%. If you don't, you only get 5%. So decision trees are slightly less complicated than decision tables. However, decision trees are usually used for simpler problems because you can only go so much in width. On the contrary, the tables are used for more complicated problems because they can fit so much. They're difficult to draw. The trees are difficult to draw compared to that of the tables.
So it would just depend on what kind of project you're working on, how big it is.
Exactly. What kind of conditions? How many conditions you're working on? Right. Exactly. Yeah.
That makes sense.
Okay. So let's take a break here, guys. It is 7:17. Let's meet back at 7:35, and then we will do some activities, some breakout activities, some decision table activities you guys will work on in a group form, and then we will, towards the end, we will talk about you guys have your presentations to give in the last hour. Okay, so let's meet back at 7:35. Okay, guys, welcome back, and let me bring up my book here. And let's quickly, as one group, we will have this discussion as a group. Go to page number 176 of your book. Read a question of ethics. We'll give everybody a few minutes to contemplate, and then we will let everybody to contribute to the discussion. Okay? So let me check back with you guys in like 3-4 minutes. Okay, so let's hear from you guys. What do you have to say about this? Who would like to start?
I think that developing a fine line between like the specific code itself and like public accessible information about the company, I think that's probably where I would start.
Okay, okay. Yes, next person. We have some chat communications also. Okay. Okay, okay. Alwyn, we read yours. Okay. Let's see what others have to contribute to this.
Yeah, I mean, I'd say it's okay to discuss like details about your last job, but I think if they're starting to ask for very specific like proprietary information, then it's clear to, draw the line in the sand and tell them no.
Okay. Wow, rest of the group is so quiet today.
So kind of let the IT manager know, hey, this is making me uncomfortable how much you're asking about this. I'll share what I'm comfortable with, but beyond that, no more questions.
Okay. Amruta, Rally, Smile, Zach, Nathan, Miguel.
Actually, I agree with Greg. Means, if like decide your comfort zone and then give the answers.
Okay.
And yeah, and not share like there is some privacy policy.
Okay.
Each company follows that rules. So yeah, don't break the any company's policy,
Okay.
privacy policy.
So privacy policy, non-disclosure agreement as stated by
Yes,
Miguel.
yes,
And Rally said, I would agree with discussing public information that's easily accessible, right? So it's pretty much everybody is around on the same path here. Don't disclose anything that is private, that's under a non-disclosure agreement. Um, anything that's public, anything that's journal knowledge, anything that you can use to make decision, but is based on your past experience, as long as you don't disclose where is your decision coming from, you don't have to do that. All of these things would be okay. For example, they hire executives from other companies because they have knowledge base of other companies, which can help them derive solutions to problems based on their past successes without revealing where those successes are coming from. That's perfectly fine, right? You're using knowledge that you learn in one company to as a stepping stone into another company where you can utilize the knowledge to make your career better. That's okay as long as you don't disclose anything.
So pretty much your skills is what you're bringing, the specific knowledge of what they're doing, like is what is proprietary.
Exactly, exactly. You're bringing in your skill sets. Exactly like you go from one semester to another. You take your skill sets to the next semester, and nobody questions you in second semester. How did you learn this skill? How did you break this code? I mean, tell me exact specifics. Which week, which instructor? Nobody does that. It's just like, okay, as long as you can solve the problem, let's move on. Okay. So that's what it is. Okay. Okay. Now, what we will do next is I want you to go to page number 171. On page 171, it talks about decision tables. So now you and in a group will now be making one, and then we will discuss that. Okay. So if I'm not wrong, I think that's what it is.
Are you talking about the case in point from it?
Yeah, case in point 5.2, rock solid outfitters. So that's asking you to
What's
make,
the page again?
that's 171.
Okay, thanks.
It's all the way towards the bottom. It's case in point 5.2. So let me create your breakout rooms and
And it's the decision table, not the tree, right?
correct. Correct. Only the table. Yes, not the tree. Okay, I've placed you guys in 6 rooms. 5 rooms have 2 people each room, and 1 room has 3 people in that room. So together, you're solving this problem. Let's put 20 minutes for this activity. So we'll see you guys around 8:08. So there you go. Okay, welcome back, guys. I believe a couple more people are still to come back. Okay, so everybody's back now. So did you guys completed it?
Yep,
Yep.
group 6.
You have 6 as a final answer?
No. Group 6 did.
Oh, okay. So how many columns do you have in your final answer?
8.
You still have all 8 columns in your final answer?
5.
5, okay. Let's have a look at
Oh
all the
wait,
problems.
that's true. I didn't cut out the redundant answers. That's so true.
Oh, okay. How about let's look at the problems statement, the way it's structured in the table format. So it's a decision table. There are 3 conditions: completed survey form condition, sign up for newsletter condition, and if order exceeds $100. If all conditions are fulfilled, free shipping and discount. If first 2 are fulfilled, but the order is not over 100, then you only get free shipping, you don't get a discount. If you sign up for a newsletter and you did not sign up for the newsletter, but you only you complete the survey form, you get a free shipping. If you only complete the survey form, you still get the free shipping. If you only sign up for the newsletter, you still get the free shipping. And you do not get a free shipping or a discount if you did not do one of the 2 signing up activities. Doesn't matter how much you order. So that's the first setup. From the setup, we realize that if you do not sign up for any of the 2 newsletters, then your order amount doesn't matter. So basically 7 and 8 are 1. Similarly, if you look at 3 through 6, there are some variations, which we'll look at in just a minute. But let's look at number 1. Number 1 is very unique in nature, where you filled out both forms, but you did not, and you placed an order over 100. And here you filled out both forms and you did not. So 1 is unique. 7 and 8 together are unique. Now we need to figure out what to do with 2 through 6. So here we look at 2 through 6. So for column number 2, both are filled. So that's a unique item when you do not place an order over 100. And now let's look at 3 through 6. In 3 through 6, it doesn't matter how much you place for an order. If you made an order of over $100 or not, that doesn't matter. As long as you only did one of the 2 activities, you will just get a free shipping. As a result, 3 and 4 basically come out to 1. 5 and 6 come out to 1. And 7 and 8 come out to 1. So there is 1, 2, and 3 columns here, 4 and 5. So that's basically becomes your final outcome. Okay, everybody got this? Okay. I am putting a case, which is not part of the book, in the chat. I will be putting you guys in a breakout room to discuss this case and then come back and report on your answers. So let me put you guys in the breakout room. This time we'll put more people in a breakout room so you guys can have a little bit of discussion here. We'll set aside 10 minutes for this discussion for you guys to be back around 8:24. So let's get started here. Then once everybody is back, then we will ask you what you guys talked about in each of your groups. So we still have 5 more people to come back from the 2 rooms. Down to 4 people to come back. Okay, 3 more to come back. 2 more to come back. And now everybody should be coming back. Okay, let's look at room number 1. Room number 1, Amruta, Arali, Ethan, Greg, Jack, Nathan, Victor. What's your take on it as a group?
So we were talking about the fact that by changing the data form, it might actually change what information is being gathered and what the storage what is necessary to store, so that is needed for the logical planning. So it's a good idea to bring it up now, because if they wait too long, it'll be harder to implement the changes necessary. You're muted again.
So that's the gist of everything you guys discussed, right?
I think we covered it, right?
Okay. Room 2, Aiden, Alvin, Ismail, Jonathan, Miguel, and Zach.
I would say we had a similar answer to what Greg was saying. We believe that improvements can always be made. Alvin said it was the system, how the system will be built, which is definitely a physical issue. We agreed that by improving kind of what she was introducing, it would kind of give room for potential employer or employees.
Okay, so if you remember at the beginning of the chapter, we talked about LPLP, the 4 model approach, where it's logical, physical, and then a logical, physical. So if she's trying to make any changes, and if there is a logical plan in place, so she may have to consider making changes all the way through. So this would probably help her develop things. If she's planning on making changes considering future, then she probably may be going off tangent, because she needs to concentrate more on what needs to be done now than what needs to be done in the future. But if what she's doing is helping her investigate it better, then yeah, she can basically make it part of the investigative process analysis, which is extremely important component for this step. So it all depends on what exactly she's trying to do with that information moving forward. Is it long-term, short-term, now, improvement in the future? Whatever it is could be answered differently on where she falls. Okay, so with that, let's move on to our presentations for the day. So let's see, let me go back to Blackboard. And as I told you guys earlier, that you have unit number 3 with chapter 5 quiz and assignment assigned to you guys, where chapters 3 and 4 with all of their items are due by midnight tonight. Okay, so let's see. So we'll mark Daniel absent, but Jack Lear is here. And Devin is also not here. Okay, so now let's get to the presentations. And let's go to the presentation number 1. Okay, so today we have Miguel, Zach, and Jack. Okay, did all of you submitted your presentations?
Me, Zach, Claude, I submitted mine.
Okay,
Yeah, I submitted mine before class.
I
okay.
haven't submitted mine yet.
Who has not submitted yet?
Jack.
Oh, Jack,
Yep.
okay.
Yeah. I'll submit it
So,
right now.
yeah, okay, cool, awesome. So I'll give Jack a couple minutes or so to submit his. Then I will go in the grade book and then I'll tell you guys how we are proceeding. You guys already know the drill, right? So the first person to go will be Miguel, then Zachary, and then Jack. Okay, so Mr. Ibarra, all yours.
Okay. Hello, my name is Miguel Ibarra, and my presentation will be on cycling. What is cycling? Cycling and biking are used interchangeably. Cycling refers to racing, while biking can be used for transportation or exercise. Furthermore, cyclists are more interested in the bike's performance, while bikers are concerned about the bike's utility. Cycling is a sport that consists of professional and amateur races that are held primarily in Europe, the United States, and Asia. One of the most famous athletes for cycling is Lance Armstrong, who has won 7 Tour de France races. The Tour de France is 21 day long stages over 23 or 24 day period and covers approximately 2,200 miles. Some of the benefits of cycling are physical health, mental health, and that they are environmentally friendly. Cycling is a great physical exercise. It's a low impact cardiovascular exercise. Unlike running, which can be hard on the body, other benefits include coordination, flexibility, and balance. For the mental health aspect, sometimes when you have a long day or the day has gotten the better of you and you're feeling lethargic, going on a ride can boost your mood by releasing endorphins, which exercise promotes. Moreover, when you go on a long ride, some people may experience a flow state. Flow is also known as being in the zone. It happens when a person performs an activity and is fully immersed in a feeling of energized focus and enjoyment. It's the balance between consciousness and action, the perfect amount of one's skill and how challenging the task is. Cycling can help reduce carbon footprints and save money on gas if you opt in to use the bike as a mode of transportation. Performance bikes, such as road bikes, is a bicycle that's built for traveling at speeds on paved roads. It has thinner tires, a lighter frame with no suspension, and drop handlebars. The one in this picture is the S-Works Tarmac by McLaren. It's valued at $20,000, and this is the pinnacle of road bike construction. The carbon fiber frame weighs a little over 1.5 pounds, and when fully assembled, the bike weighs around 14 pounds, depending on the size. When buying a road bike, there are several specifications to look for. The main ones are a lightweight frame, wheels, and components such as cranksets and brake levers. Furthermore, picking the right size frame is crucial because if you get a frame that is too small or too big, you run the risk of injuring yourself. The best option would be to talk to a bike dealer and get the measurements for the perfect fit. For an entry-level bike, I would recommend an aluminum frame because they're cheaper than a carbon fiber frame. And an excellent entry-level price tag would be around $500 to $1,000. But if you're looking to be the lightest and fastest, carbon fiber frames would benefit you the most. But they do come with a heftier price tag, with bikes ranging from $2,000 upwards to $10,000. Some of the equipment are helmets, sunglasses, which when you're riding a bike, the helmet is the most essential piece of safety equipment because it will mitigate head trauma if you have an accident. And sunglasses protect your eyes from the sun's glare or bugs that can get in your eyes. Furthermore, the shoes, you don't necessarily need them for cycling. You can use flat pedals, but having the special shoes gives you better power transfer to the pedals, which equals more speed. A downside to the cycling shoe would be that if you aren't familiar with them, you run the risk of falling over when trying to disconnect from the pedal. Another aspect would be water, which is going to be very crucial. It's going to be your lifeline when you're cycling for extended periods. You're going to be sweating, burning calories, so you must stay hydrated. Fueling your body is one of the most important aspects before going on a ride. Depending on the length, you want to fill your body with slow burning carbohydrates at least an hour before, such as oats, sweet potatoes, or quinoa. During the bike ride, many people like to eat sugars, such as jelly beans or a quick carbohydrate like a banana. Another alternative is an energy gel that's pretty much a concentrated, quick absorbed form of carbohydrates. Immediately after you ride, you want to eat something high in protein, like a protein bar, because protein is vital for optimal muscle recovery. A few hours after the protein bar, it's recommended that you eat a well-balanced, nutrient-dense meal. One of my go-to meals would be a lean protein like chicken breast and a stir fry. And that concludes my presentation. And here's a nice little quote from John F. Kennedy that I really enjoy.
Nice, good job. And yep, you executed it nicely. You executed it within time. I don't know about other people, but it was a nice set of information. And does anybody has any questions for Mr. Ibarra?
Are there any does it really make a difference if you have like a $1,000 street bike compared to like a more higher end bike? Like, does it make that much of a difference compared to like your ability and your stamina and other things that you can control besides the design of the bike?
Yeah, great question. Lance Armstrong, he said it perfectly. He pretty much said, when it comes to cycling, the bike is the most important thing. So it does make a big difference. So if you're having an aluminum frame, yeah, you can still go fast, you can go long, but it isn't going to be as light, it isn't going to be as agile, and it won't be as comfortable as, say, a $3,000 bike. So the price tag really does kind of determine how good and how well you perform on the bike.
Okay, perfect answer.
And I was surprised to hear that some of them actually can run to like $20,000. Wow.
Yeah, they made that McLaren and Specialized collab, and they only made 250 of them. So $20,000, I mean, that's a car right there.
Exactly. Exactly. Wow.
Probably precision machined too. Like,
Oh
very
yeah,
specifically made.
yeah. They had Formula One engineers help build the bike with they had a program that could pretty much map out the entire bike, how it's gonna ride, how it's gonna feel, pretty much the ins and outs before even making a mold of the bike.
Amazing. And I was not aware of the special shoes for biking.
Yeah, if I actually go back here, the cleats they're called. Um, so these right here, they actually clip into the pedals and they lock your foot in essentially. The only way to get out is to kick your heel out to the left or to the right, depending on what foot. So they are really beneficial, and I highly recommend them if you do consider taking up cycling.
Nice. Thank you.
Ever go to the velodrome in Kenosha?
I have not. No, I never rode any bikes here in Racine or Wisconsin. I lived in California for a while, and that's when I picked it up. So I did all my riding out there.
So much easier out there too.
Oh yeah, beautiful, right along the water. You can't beat it.
Wow. It's pretty cool. Nice. What made you move up here?
I was actually moving around with my girlfriend. She was working and she was traveling from state to state, country to country. So we finally settled down here in Minnesota. So that's where we're at now.
Oh, okay. Oh, so you are in Minnesota
Yeah, currently I am.
currently. Okay. Okay. But for some time you were in Racine.
Yeah, I grew up in Racine my whole life. So yeah, that's when I started Gateway. I was in Racine.
Oh, wow. I didn't know that you are not attending classes from here. Okay. So you started the program when you were here, but now you're in Minnesota.
Correct.
Wow. Cool. Thank you. Thanks a lot. Okay. So okay. Zach, you ready?
Yep, let me present this and share my screen real quick.
Mhm.
All right, can you guys see my screen?
Yes.
Yeah.
Okay. So I'm Zachary Cloud. My presentation is on the snow sport skiing. So skiing is a snow sport that involves using snow-covered mountains as slopes to slalom down to the bottom. By using smooth, flat planks on your feet, you're able to float across the snow and glide at great speeds along these snow-covered hills. You're able to float across the snow. Some people take skiing to much greater distances, and it takes a competitive level by starting to perform stunts. I'll cover that later in the presentation. Skiing and snowboarding are very hand in hand, in which skiing you're facing forward and have control over both your feet. In snowboarding, you're sideways and your feet are locked into a board. So equipment used in skiing is very important. The skis contain fixed heel bindings, which work in unison with a boot that locks into the ski, leaving a secure connection between the two. The connection may be secure, but they can still come apart in case of an accident occurring, whether it's like your ski kind of digging into a mound or something similar to that. You don't want your foot to be locked in and then you break your ankle or something. And then the other thing are ski poles, which are typically used to put yourself forward on flat grounds. They aren't required. When I went skiing, I didn't need to use them. You could kind of, if you've gone roller skating before, you can propel yourself forward by pushing your feet off to the side. That's what I did for a while. However, it's much easier to traverse using ski poles. And then the last thing is winter gear. Typical winter gear includes a heavy jacket, helmet, goggles, snow pants, a face cover, for example, a scarf, gaiters, and then gloves, of course. So the competitive skiing, more often known as extreme skiing, with years of experience, people have started implementing hills, rails, and other techniques to take skiing to the extreme. One of the biggest tournaments held, also known as X Games, holds hundreds of contestants that compete to see who can perform the most dangerous stunts. Many techniques used in skiing have been inherited from traditional skateboarding stunts and are performed much differently. So a lot of these things you see that I have listed are pretty commonly used when you're skateboarding, and kind of skiers kind of just took over and started using those on snow-covered slopes as well, and people build them along the slopes and can use them to do similar tricks on a skateboard as you could on skis or snowboard too, for that matter. So why should you ski? Skiing is great for your physical exercise. For example, it improves conditioning. It's very hard on the legs. It's a lot of repetitive leg motion where you're slaloming back and forth, left and right down a hill for up to 8 hours a day, if that. It's very exhilarating. Being at the top of a hill or slope also contains beautiful scenery to look at. You're extremely high up on the slope, and there, when you get to places like Colorado, there's just beautiful mountains you can just stand on top of and just look all around you and view the scenery. Skiing can be an extracurricular sport. You can do it after school. In my high school, there was a ski club where they paid for your schooling as well as paying for your skiing. That was a great activity I did a lot back then. And lastly, of course, it's fun. It's a blast to cruise down the snowy slopes, and to do it multiple times a week is more than enough to ask for. So, although skiing is great, there are some cons to it. Some of the downsides, they can be dangerous, expensive, repetitive, and strictly winter. So, people that are fans of heights or high speeds, they might not be a fan of skiing because most of the time you are going to be sitting at the top of a mountain, and you'll be traveling very fast down the mountain as well. You're very aerodynamic when you're sliding down the mountain, and someone like my mom, for example, is not a big fan of skiing. I used to take her all the time, and she was always afraid to go down the big slopes, but I was the daredevil and I always wanted to do it. um as great as the sport is, it's very expensive, whether you're paying for your own equipment or rentals. The price adds up very quickly if you are paying for rentals. Along with that, you have to pay for a lift ticket, which is the ticket that requires you to operate the ski lift to take you up the slopes. Some people find it to be repetitive. I personally don't, but most of the time you are spending more time going up the ski lift as opposed to actually sliding down slopes. And then the last thing, unfortunately, it's very strictly winter based, or it's in much colder areas. So it's very restricted to where you can actually ski or what time you can ski. That concludes my presentation. If there are any questions.
Okay, cool. You were in time, within time. That's kind of nice. We do it like within
Perfect.
6 minutes. That's pretty nice. I mean, I'm glad. I mean, like you covered all aspects of it, not just from health perspective, but also from safety perspective. So it's kinda nice.
Absolutely.
Yep. And does anybody has any questions for Zach? if I'm not wrong, you said earlier that some of the tricks are learned from the roller skates.
Yeah, skateboarding. Yeah.
Skateboarding. Okay. Okay. It's pretty interesting. The only
Mhm.
difference is that if you fall on a softer surface.
Right. Yeah. It's a lot more there's a lot more room for error, I guess.
Yeah. Yeah, you're true. You know, I mean, like, that's just pretty cool. Cool. Thank you. Thanks a lot.
Awesome. Thank you.
So,
Hello?
yes, Jack, just give me 1 minute. I am just getting to yours. Okay, go ahead.
Okay. Does my microphone sound all right?
Yep. Sounds
All right,
perfect.
cool. Let me share my screen. Oh,
You can click on enable. Yeah, got it. And then, yep, from the beginning.
yep. All right. And I apologize if you hear my cat meowing at some point during the presentation. He's loud. Um, my name is Jack Lier, and I've decided to do my presentation on the hobby of custom mechanical keyboards. What is this hobby and what are custom mechanical keyboards? Um, this is a hobby that involves um, acquiring the individual required pieces to assemble a working mechanical keyboard and then building it yourself. This is something that is potentially for everybody here. If you use a keyboard regularly, which I know everybody here definitely uses a keyboard regularly, then this may be something that you would be interested in. The hobby is fulfilling, as you can see that your keyboard is coming together and it can be extremely personalized with you being able to choose each of the pieces yourself. Mechanical keyboards are they're made up of only a handful of parts that you'll need to get. These parts include the PCB, which is the circuit board of the keyboard, the case, which holds everything together, the keycaps, which connect to the top of the switches and are the pieces that you touch when typing. It has the letter that you type on it. And last but definitely not least are the switches, which are what registers the keystrokes of the user. And mechanical keyboards are named after their mechanical switches. The switches can be regarded as the most important part of the mechanical keyboard. The switches of a mechanical keyboard are underneath each keycap, and when the switch is pressed, a keystroke is registered. And unlike membrane and rubber dome switches, like those Apple Magic keyboards that come with the Macs, mechanical switches have individual components that work together for each key. Cherry MX is a brand or a company that produces switches, and they're probably the most well-known company that creates mechanical switches. I know Corsair uses Cherry MX switches for a lot of their keyboards. I think my first mechanical keyboard was Corsair, and it had Cherry MX Reds. When deciding what switches to get, you'll have to choose between 3 different varieties. That would be linear, tactile, and clicky. Choosing which variety you prefer is completely up to personal preference. Linear switches are what you see in the animation to the left in red. These are Cherry MX Red switches, and you can see as the switch is depressed, there is no bump and it goes down completely smooth. And tactile switches, there's a bump on the way down that gives a tactile feedback before the switch bottoms out. The animation to the right, there's these switches are called Cherry MX Blues. These are of the 3rd variety, which is a clicky switch. You can see there's more moving parts. It's the same as a tactile switch, except that there's a distinct audible click noise when they're pressed. And I've built one keyboard, and something that's kind of funny that I'll mention. The first keyboard that I built, I for some reason decided to pick up certain switches that were and still are very coveted. And the switches are not usually this pricey, but the switches that I picked out were rough or maybe slightly over $1 per switch. And it may not sound like much, but if you're making a complete keyboard with many, many keys, it definitely adds up quickly. The case is the outer shell that houses all of the internal components. Custom keyboard cases come in a variety of materials. You can get them in aluminum, plastic, or acrylic, or even wooded. I've seen wooded keyboards, wooded cases. Each material affects the weight, look, and the overall sound that the keyboard produces when you're typing. When choosing a case, you'll have to figure out your desired size of the keyboard that you'll need. In the image to the left, it shows a variety of different sizes, and the size of keyboards are measured by a percentage, and this percentage of how big it is in relation to what is considered a 100% or a full-size keyboard. And that includes the entire numpad and the arrow keys and all of that. The PCB, which is what you see in the image on the bottom, is the circuit board that connects all of the switches and also connects to the computer. On the top left, you can see that there's, I think that's a USB-C, and it would connect to the computer with the USB-C to USB-A. USB-C or PCBs can have options such as like RGB lighting or macros, so they can vary in that type of way. And it's important when you're picking your parts, like a PCB, that it's compatible with your case, because not all cases or PCBs are compatible with each other, but all switches or all keycaps are compatible with all switches. And the keycaps, these are the most visible part of the keyboard. And these are where people get to choose how their keyboard is going to look. The image in the top middle shows some keycaps with like an orange cat type of aesthetic, where there's, you know, paw prints and cats and such. Yeah, there are so many different types of keycaps. Keycap sets is what they're called. You're guaranteed to find something that you'd like. As well, the case, or like the case, I mean, materials for the keycaps can vary, such as metal keycaps, ceramic keycaps, or textured keycaps, and much more. And I'm willing to answer any question that anyone may have related.
So what are some really good feeling switches?
So the switches that I got are called Holy Pandas, or the brand is, I think, Drop. That's like the main distributor. But there's plenty of videos of people doing like showcases of various different switches and how they sound, and or build videos and stuff like that. But I used Holy Pandas for the first one because of how good they sounded.
Are there any benefits to having a smaller keyboard?
Yeah. Maybe you don't have such a large desk, or you want more mouse room. Maybe you're using it purely for playing games rather than coding, because you'll need a larger keyboard to get every single like insert, home, delete, arrow keys and all that, which would be a lot more helpful in things like coding or typing.
Okay. Anybody else has any other question? Okay, so Jack, you went a little bit over, like a minute and a half. And
That's, I tried to, because when I tested, I kept going under. So I kept trying to go, I had in my mind, I was like, all right, I have to talk very slowly.
So something that happens as you're doing the presentation is you will get nervous, and that also will slow you down from what you're metering yourself at from before. So add a little bit extra to whatever you meter yourself at.
Okay. Well, the way it always happened to me is that it was, when someone's nervous, they speak very quickly to get it over with. So that's what I assumed. So
cool. Thank you for your presentation. It was nice learning about so much about keyboards. I didn't know that much about keyboards because mainly I use them for coding, so I need large keyboards. I don't like small keyboards.
Neither.
I used mechanical keyboard. In fact, that's the one that I use for my desktop, and it's I can change colors on that keyboard.
nice.
But the only thing I don't like about it is when the reflection from the monitor makes some of the keys not so visible.
Like the backlighting of the keyboard, maybe? Or no?
It's probably because the keyboard is not matte finish.
Okay.
It has a bit of shine to it.
That's
So
fair.
the light from the keyboard
So
or overhead
sheen,
light.
maybe?
Say it again?
So sheen, maybe?
Yeah, something like that. I don't
Yeah.
know what
And
makes keyboard
there, yeah.
becomes difficult to see the keyboard at times.
Yeah, and that's the keycaps. So you could definitely, there's plenty of different things where there are matte finishes or different textured type of keycaps that would be more to your liking.
Yeah, and I never wanted to spend that kind of money on it because
Yeah.
the keyboard was not that expensive.
Mhm. It's a yeah. It's an expensive hobby, I guess.
Yeah,
Definitely.
yeah.
So were you saying you have one that has backlights? The
Me? Yeah,
keyboard? Yeah.
yes.
So the ones I have actually have like a part of the keycap that is see-through, so you can see the light
Mm.
coming through. So that makes it easier for me too.
I
Oh,
tried
I see.
turning all of them off sometimes when I'm coding, but still, I think because of the reflection on the keyboard surface itself, on the keys, makes it difficult for some of the keys to be visually there.
Mhm.
The ones that are closer to the screen are the ones that are the most difficult to see. So yeah, I mean, I don't know. I mean, and for my Mac, I do have a Mac keyboard. And if you ask me, I like keyboards that make less noise. So
It's all
yeah,
yeah, it's all preference.
So you don't like the old IBM Model M's.
you know,
My
that's the
yeah, my
thing.
brother
I
has one of those
switched.
too.
I
Very
switched
loud.
from the quieter keyboards. I used all quieter keyboards during COVID. And then after COVID, I switched to mechanical keyboards. I used them for a year or maybe 2 years, I think so. And then now I'm switching back to quieter keyboards.
Greg, something that's funny, what you based on what you said, the Model M, when it came out, people considered it too quiet because they were coming from typewriters and they didn't like how quiet it was. Except nowadays it's very, very loud.
Yeah.
Yeah. And people are actually now circling back to try to
Right.
get those type of key feels and everything.
Exactly.
I mean, the sound of it's very soothing to your ears, you know?
hmm
You know, I mean, like you
It's
can
like,
really,
yeah.
yeah.
As long as you're
I'm a
not in like
tech
a
genius.
Dude, I
cubicle
spent a
farm hearing it the
lot of
whole time.
money. I spent a lot of money on my keyboard just because it sounds nice.
The only reason I moved away from it because I don't know when I'm teaching on Zoom how much sound it produces because my mic is on all the time. So
Mm.
I don't know if you guys continuously hear the click, not now, but last semester.
I think Zoom has a built-in noise reduction or compression. So I think it should I don't remember hearing anything like that.
Okay.
Yeah,
Okay.
I think they actually use an AI sound gate kind of thing for it.
hmm
Oh, Zoom uses it?
Yeah,
Oh, okay. That's cool. Yeah, that's nice.
fancy.
Yeah, but I actually have a